Okay, pre-cal, this is the last video for transformations. So we know how to identify the transformations in order. That's the first thing we learned how to do. And then we talked about the idea of, hey, here's my equation, graph with the transformations and find the domain and range. Now in these last two examples, I've given you the graph and you're going to now write the equation. So the best way to do these is to first identify the function that you're dealing with. So this is, of course, a parabola. So I know a couple of things about this. I know that the parent function looks like this. Y equals x squared, right? Or f of x equals x squared. So I know that that is what my parent equation looks like. So I'm going to use that idea to build my equation after I determine how the parent has transformed. So the first thing I'm going to do is see if I have any stretching or shrinking here. So if I look at this, there's my vertex, and if I count over 1, down 1, over 1, down 1, over 2, down 4. Okay, so that's exactly the same as a parent function. So there are no stretches or shrinks here. But it's obvious to me that I have moved to the left by 4, and I've also moved down 2, and I have reflected over the x-axis. So these are the things that are happening. So now I've got to translate that into the equation. Well, I know if I've got a reflection over the x-axis, that means that there's going to be a negative out in front of x. And since I have a left 4 shift, I know I'm going to have parentheses. So since it reflects across the x-axis, the negative goes outside the parentheses. If it reflected over y, it would go inside the parentheses in front of x. So that's how I make that determination. Since I'm moving to the left 4, this means I'm going to have x plus 4 in my parentheses. Don't forget this is a parabola, so you must put a square up there. Now down 2, so that's minus 2. So that is my equation. That is my answer for this particular graph. Okay, now remember, I have stressed with you that with a square root function, order's really important, and this one has a reflection, so it's super duper important. So I've got the square root function here. So if you will look at what's going on here, let's look at the parent function. It would look like this. So it's obvious here that I've got a reflection. So let's think about this. So let's say I reflected it from where I am right now. It would reflect that way. Well, that doesn't work with what I have, does it? So if you'll think about this, you may have to play with this a little bit to figure this out. Okay, so I know that I have a reflection, and I know it has moved away from the vertex. So let's try some things. So let's say we move to the right 3. 1, 2, 3. So this would move that just like that. And then what if we reflected it over x? That doesn't give me that. Okay, so that's not going to work. All right, so if I've got my parent here, let's say I move to the left 3 and reflect over the x-axis. Well, that's not going to work either unless I have another reflection. Because if now I take this and I reflect it over the y-axis, that's going to give me that. So what's happening here is the function is moving left 3, so that left 3 movement, and it is reflecting not once, but twice. So it is reflecting over the x-axis, then it's reflecting over the y-axis. So I know that my function equation looks like that. That's what my parent looks like. So now I have to figure out what to do with this. Well, if it's reflecting over x and y, that means I'm going to have a negative outside my radical symbol. And I'm also going to have one inside. So I've got x here. If it moves left 3, that's what I'm going to have right there. Another correct way to write this is if you treat that negative right there just like that, and just kind of just factor it out so that you're left with negative parentheses x minus 3. These are both the same thing. Okay, hope that helps. Hope that makes your homework a total breeze.